Welcome to Air Academy Associates series on using SPC Excel. In this video clip, we will show you how to determine the sample size for estimating both a population mean and a population proportion. We will also show you how sample size is related to the concept of a confidence interval. One of the most common questions asked in the history of data collection is how much data do I need? In this short, humorous, but actually quite true video clip, you will see an interchange between a biologist and a statistician.
I have a study, and I need to know how many patients I need. I think I only need 3 patients.
Okay, what kind of study is it?
I'm doing a lab study. Can I just use 3 patients?
That depends. What are you trying to show?
We always use 3 patients.
Okay, what are you trying to show?
I'm trying to show that drug A and drug B are better than only drug A.
How are you measuring if it is better?
We are looking at apoptosis. Can we just use 3 patients?
What kind of measure of apoptosis? Do you know how variable that measure is?
We always use 3 patients. That is what we have published before.
3 patients per group or in total?
Yes.
Okay, let's try something different. What type of measure are you using? And is this an in vitro study? An in vivo mouse study?
It is an in vitro study of patient samples, and we are looking at measures of apoptosis after treatment with drug A and drug B versus drug A and control, and drug B alone.
Oh, how many groups are you analyzing altogether then?
My grant is due tomorrow. I just need to know if I can just use 3 patients per group.
Okay, well, you probably should have come to me earlier for help with this.
Obviously, the answer to how much data do I need should not be answered with that's the way we've always done it. So this page again is designed to show you how the sample size is related to a confidence interval. For those of you who do wish to skip over this, that is fine, but this gives you a little background on where sample size is coming from and how it's calculated. In a estimation problem of generating a confidence interval, we have a point estimate and we have a margin of error. This margin of error is also called the half interval width in SPC Excel when we go to calculate sample size. It's given the value of H in this equation right here. This is the way it is calculated, and it's based on this margin of error, which in sample size calculations the user gets to specify. In a confidence interval, the standard deviation, the sample size, and a measure of the degree of confidence are all used in the calculation of the margin of error. In a sample size calculation, the margin of error, the half interval width, is specified, along with a couple of other things that will help the software determine and calculate the sample size. Same thing with a population proportion. We have a margin of error, which is also called the half interval width in sample size calculations, and specifying this allows the software to calculate the value of n. Now, practically speaking, the practical question is, how much data do I need to get a good estimate? The correct answer is, as that little film clip indicated, it depends. And sample size depends on 3 things. First of all, what is the population variation? And for binary data, when we try to estimate a population proportion, variation is a function of P, which is the proportion of the category of interest in the sample. So population variation is important. The other question is how much precision do you want in your estimate? This is where you specify your margin of error, or what the software will call here shortly your half interval width. And then the last thing you need to specify is the level of confidence. And so let's take an example here for estimating a population mean. Suppose in a customer response time example, we have calculated a 95% confidence interval for the population mean as 20.9 minutes plus or minus 3.82 minutes. This was based on a sample size of 10 with a sample average of 20.9 and a sample standard deviation of 5.34. Suppose instead of this 3.82 margin of error, which we consider to be too much, we want to estimate the true mean response time to within plus or minus 2 minutes. So we're wanting to cut this down from 3.82 almost in half to 2 minutes, but still have 95% confidence. How big would the sample size have to be? So to answer that question, we would go to SPC Excel, Analysis Tool, Sample Size, Normal Confidence Interval, Mean. And we would have to specify these three things. That is the estimated standard deviation, which in this case we had from a sample of 10, which we might call a pre-sample, a small pre-sample. The half interval width is specified by the user as 2 in this case, and the confidence level is given as 95%. In this case, we would need an estimated sample size of 28. So let's go to the software and actually demonstrate this. Now we are in SPC Excel, and where we go to determine sample size is to Analysis Tools, click on that, down to the last menu item here called Sample Size, click on that, and since we're interested in estimating a population mean, we choose the normal confidence interval mean here for that. So click on that and we get this user interface menu that has the three things we have to put in there. And from our previous sample, we know that standard deviation was 5.34 minutes, and the half interval width we want in this case is 2 minutes, and we want 95% confidence, and there is the 28 that we had talked about before. Now clearly there's a relationship between these elements in the calculation of sample size. For example, if you wanted 90% confidence, the sample size is going to go down. If you want 99% confidence, the sample size is going to go up. Let's go back to our regular 95% confidence with a 28 size sample. And if your half interval width, if you want more precision and you cut that down to 1, what do you think that's going to do to your sample size? Watch this. It quadruples it. Since a halving of the interval width, it almost makes your sample size 4 times as big. So the original was plus or minus 2 minutes is what we wanted our estimate to be. And of course, as the standard deviation goes down, say you had a smaller standard deviation of 4, that will allow the sample size to be smaller. So less variation in your population, the smaller the sample size has to be. So it's very important to get a good estimate of the standard deviation in your population. So let's go back to looking at the different values here that are shown here in the user interface, where the user must specify these three things. Now, it's pretty easy actually to specify the half interval width or the margin of error. And it's pretty easy to specify the confidence level. But where do we get the estimated standard deviation? Now, in this example, we got that from a pre-sample. But the key is, where do we get this value right here? There are several areas where you can go to get that data. Historical data is one place. Go to some similar process that you have data from before. Calculate the standard deviation. You might be able to use that. A small pre-sample of data like we did here with a small sample of 10. Or you can make an estimate. And that is, what range would you expect to get in this particular process? So suppose we expect times as low as 5 minutes and as high as 30 minutes. And let's suppose 95% of the times are expected in this range. Well, a very easy calculation to estimate this is take your range, which is 30 minus 5 or 25 minutes, divide it by 4, and that is about 6.25 minutes. So one could use this. The range divided by 4 rule of thumb is a nice little rule, because estimating range is easy, and the division by 4 comes from plus or minus 2 standard deviations, accommodating 95% of your variability. So that was for estimating a population mean. What about for estimating a population proportion? Well, we have the same kind of menu item, interface items that we have to specify. And suppose that in a travel voucher example, we have many travel vouchers that we're processing, and we have errors in the travel vouchers. And let's say that we would like to estimate the true proportion of travel vouchers with errors to within 3% with 95% confidence. Now we're going to go to Analysis Tool, Sample Size, just like we did before, but in the case of proportion, we're going to use the Binomial Confidence Interval Proportion option. We still have the same interval width. The only point here is if we want a 3% margin of error, that is specified as 0.03, because we're looking at proportions here. 3% is 0.03. The confidence level is still given in terms of percent, and then we have to specify the proportion of defectives, or in this case the proportion of vouchers having errors. And we can get this from historical data or a pre-sample. If this is unknown and you don't have a way of legitimately getting a good estimate, the most conservative or worst case estimate can be put in there as 0.5. A 0.5 there will produce the greatest sample size possible. But let's say in this case we have a 0.1, we say about 10% of our vouchers in the past have had problems or errors. So then you put 0.1. Again, you don't put the percent there, you put the proportion or 0.1. That's what this P represents, a proportion of defectives in the population, our estimate of it, and 0.03 would give us a sample size of 385. So let's go to the software and take a look at this option. So in the software, the SPC Excel main menu item, to go for calculating sample size for a proportion, we go into Analysis Tools, come down to Sample Size, just like we did for the population mean, but this time we want a population proportion. So we click on that and we get a very similar user interface menu. And as it says here, the half interval width is the desired margin of error. For example, to estimate the proportion to within plus or minus 2%, the half interval width is 0.02. So in our example, we wanted a 3% margin of error for this voucher problem, and our proportion of defects was estimated at 10%, and that's where we put in the 0.1. See, we want a 3% or a 0.03 margin of error, and we want 95%, and here we get the 385. Now that looks like a very big sample size, 385. Remember now, we are in the business of binary data. And whenever we're in the business of binary data, you can expect to see fairly high sample sizes, like this one at 385. So again, you can change if you want the 99% confidence, that will go up. If you want to cut your margin of error from 3% to 2%, that will put your sample size up. And you can look at the different variables here. Let's go back to our customary 95%, and let's go back to the 0.03, and you say, well, we can't afford 385. We just cannot afford to take the time to look at 385. There's a nice little trick in Microsoft Excel. If you go under Data, you can come in and do what is called a what if analysis. And if you click on that and you say Goal Seek, and you say the greatest number of samples I can look at, I can't afford to look at 385, so you say set cell, this value right there, let's change that to say the most we can look at is 200. So we're going to change this cell right here, C10 to 200, by changing another cell. And that would be, let's say it's the confidence level. That is, obviously, if we're going to change 385 to 200, what's our level of confidence going to drop to? And you say, okay, and if that goes to 200, then your confidence level, the best you're going to have, is 84.22%. It's a nice little trick that many people in Microsoft Excel don't know about. Where you find that is up here under Data, and you go to What If Analysis, and you say Goal Seek, and you can change any one cell. For example, if we want to make this back to 95, let's stay at 95, but we want to change our half interval width, our margin of error. So let me cancel this and change this to 95% to get back to the 385. But in this case, let's say we want to maintain the 95% by using a sample size of 200. Let's see how our half interval width would change, because we're looking at a 3% margin of error. So let's go to Data, What If Analysis, Goal Seek, and let's change this guy again to 200 like we did before. And then by changing which cell? This cell right there. And if we click on OK, now our margin of error with only 200 is going to be about a 4% margin of error, not a 3% margin of error. Again, this is a nice little avenue to allow us to specify something in the sample size and then back off either with the confidence level or the half interval width level. So a few little tricks there that you can use with Microsoft Excel and the binomial sample size. You can do this also with the normal sample size where we had a sample size of this, and you can see how your confidence or your half interval width will drop. Thank you very much. Again, the area where you go to get this is in Analysis Tools and Sample Size. And what we've looked at today is the mean and the proportion, the normal and the binomial avenues for generating sample size. Thank you very much.